Alright, hi everyone. Let's continue with our data structures and algorithm series. In our previous video, we implemented the push method, basically adding new node at the end of the linked list. And today we are going to implement the pop method, basically removing a node from the end of the linked list. For example, you can see I already have a linked list over here, and all we need to do is remove the last node of it. In this example, that has value 1. Also, if you remember, we always maintain two properties. One is head and the other one is tail. In this case, 1 will be our old tail and 6 will be our new tail. Now, before directly jumping onto the code sandbox to implement the pop method, there is one important thing that we need to discuss. So we can remove the tail directly, right? You can simply make the property this.tail as null, but there is one challenge. You cannot make the last second node as your new tail directly because we do not have a back pointer, right? This is a singly linked list, and nodes in the singly linked list always points to the next element. As you can see, 10 is pointing to 5, 5 is pointing to 7, and so on. But 7 is not pointing back to 5. In our case, where we want to make 6 as our new tail, after removing 1, we cannot come to this node. Why? Because there is no back pointer, right? So how can we set this second last node as our new tail? For that, we have to traverse the complete linked list, meaning we have to start from here and then move forward one by one. And once we reach the end of this linked list, we need to keep track of last second node and then make this node as your new tail and make sure this node points to null instead of pointing to this 1, right? And that's how we will remove the last node of the linked list. Now let's try to see the pseudocode for pop method, which will help us in understanding it better, and then we will implement it in JavaScript. Cool. So this is the pseudocode for pop method. The first step will be return undefined if there are no nodes in the list. Basically, if you do not have any node in your list present, then there is nothing to remove. We can simply return undefined. Else, if there are few nodes in the list, then we can loop through the list until we reach the tail. Set the next property of last second node to null, as we discussed here. Once we reach to last second node, set the next property to null, and then update the tail property of the linked list by setting the last second node as your new tail. Also, as we were tracking the length of linked list, right? So we need to reduce it by 1 because we are removing one node, and the length will reduce, and in the end simply return the removed value. That's all. That's what we need to do to implement the pop method. Now let's jump onto the code sandbox and implement these steps one by one. Alright, so this is the one which we implemented in our last video, the push method. In the same manner, we will have a pop method here. We don't need to accept any value here because pop will always remove the last node of the linked list. For now, we can close this preview tab. Okay, so the first step is return undefined if there are no node in the list. For that, I will just add a if condition here. If there is no head, then simply return undefined. You can also utilize the length property. If your length is 0, then simply return undefined because there are no nodes in the linked list. Alright, now as per the pseudocode, the next step is to loop through the list until you reach the tail. Before starting the loop, we have to define two variables here. One will be for our new tail, and second for the current element when we are looping through the linked list. That will tell us on which node we are right now. So I will just write let current equals this dot head, because we are going to start the loop from the first node, right? So we have to start from the head. And next variable will be let new tail equals current. Now why I'm initializing new tail with current, we will see it in next step. So we have to start a loop, right? We have to loop through the linked list, and this loop will keep on going until we reach the last node. So current dot next, I will just simply write here. Why? Because let's say you reach the last node of the linked list, and we all know last node always points to null, right? So once you get null here, this loop will break. And now while looping through the linked list, we need to take care of our new tail, right? So we will simply do new tail equals current, and current equals current dot next. Now let's try to understand this part. Now let's say you have a linked list 1, 2, 3 and 4. Now we have to perform the pop method here, meaning the final outcome will be 1, 2 and 3, right? Now how this loop will work? First we will have the current variable here pointing to the head, right? And new tail also, so I will just denote NT here for new tail. Now this loop will check whether current, which means your head, has a next property or not. And now if you look at the example, yes, the current element or the current node is pointing to 2, so it has dot next property, and we are assigning current node to the new tail, assuming this is our new tail, and then we are setting current equals to current dot next, meaning we are moving or shifting our current node variable to the next node. And then once again this while loop will check whether current node has dot next property or not. If you see the example, yes, it has the dot next property, which is pointing to the node 3, and then we will assign the current node to the new tail variable, meaning moving new tail to the next node and then assigning current dot next property to the current node, meaning moving to the next node. Now again going back to the while loop condition, checking whether current has dot next property or not. Yes, it has. Same process, we will move the new tail variable to the next node and then move current to the current dot next, meaning current will reach here. Now going back to the while loop, I know it's a long process, but it's important to understand how exactly it is working. So here, do we have current dot next? No, because 4 is our last node and last node always points to null. So there is nothing, meaning we will not go inside this block. And if you also see here, new tail is now pointing to the last second node, meaning we have successfully got our new tail. I hope it makes sense to you. And now let's look at the next step. We have successfully completed the second step, which is loop through the list until you reach the tail. And now we have to set the next property of last second node to null. And also we need to set the last second node as our new tail. Now let's set the last second node as our new tail. So this dot tail will be new tail, and then we have to do this dot tail dot next equals to null. That's what our pseudocode says. See, set the next property of last second node to null. This is last second node and its next property will be pointing to null. And now we have to reduce the length property by 1. So this dot length minus minus, and then we have to return the removed value. Now how you will get the removed value? Simple, your current variable is still there, right? You can simply return the current. Alright, I think all set, or maybe there is something I have just got. So there is one more case that we need to handle. If this dot length is equal to 0, then we should reset our head and tail property, right? So this dot head will be pointing to null, this dot tail will also be null, right? Because if there are no nodes in the linked list, then your head and tail should point to null. Now let's try to run this in our console. Alright, from our previous code, we already have a linked list here that has nodes 1, 2, 9 and 10. You can quickly see. Yep, we have. Now what I will do is simply perform a list dot pop here, and then I will do a console dot log here as list, right? This is our list instance. Now if I show you the linked list, you can see node 10 is already removed and node 9 is pointing to null right now, which means our pop method is working fine. We will do one more test here. I will just copy paste. As you can see, now we have 2 nodes left in our linked list, because previously we had 4 nodes, right? And after calling dot pop method twice, we will left with only 2 nodes, which is 1 and 2. And you can see the last node is 2 now, which is pointing to null. I will just call it 2 more times, and now you can see the length is 0, head is null, tail is also null. And now if I call it again, it will do nothing. It will simply return. Why? Because we have a check here, right? If there is no head, then return undefined. I think I haven't shown you the returned value, right? I was just logging the list, the complete list. I will just do a console.log for the list.pop. Cool. and then I will simply remove these pop methods. Let me just refresh. You can see this is the returned value, the current element which was removed. Cool. So that's all for this one, and in the next video we will cover few more operations that can be performed on simply linked list. And thanks for watching.